what we're doing today is mixing up all of the different kinds of factoring. So yesterday, I think everything was complex trinomial factoring. I think for some people it becomes quite a bit more difficult when there's different types. Okay, and you have to first of all decide which type you have and then do that. And sometimes there's like 2 types involved in one question. So again, practice is a big part of how you'll improve in this area, but there's a few things that you can look for. So we're going to write them out and we're going to talk about them and show some examples kind of what the different ones will look like. I don't know that you could memorize this list. That would be a bit of a pain, but you could refer to it while you're practicing, and then hopefully through practice you'll get better at it. Okay, so here's the different types, the summary of the different types factoring that we will see, and we'll show examples of them. And then in terms of how you factor them, well, we've already covered that, but we'll do a bit of practice. So the first one that we always want to talk about is common factoring. Common factoring can have any number of terms, not one, because if you have one term, you're not really doing anything interesting, but it could have 2 terms or 3 terms or more, right? You could always have a common factor. And notice that it says always, in big capital letters, look first and last. If you notice a common factor first, you're going to make your question way easier, which is a good thing. And depending on what you're doing, if you don't notice it, it's usually harder to notice it later. For whatever reason, people very rarely remember when they're done. Like it says first and last. So if you think you're finished a question before you move on, you might, if you're factoring, it might be a good idea to look for a common factor again and see if there is one that you missed. But people forget to do that. So you really, really, really want to spot common factors first. And as they come up and as we're doing examples, we'll look at what to look out for. I'll try to give you a couple of tips. It can be tricky. You have to remember to do it. And again, I talked about this yesterday. Like, you know, your numeracy kind of has to be good. Your times tables kind of have to be good. It does take a little bit of work like that, but you can do it. When we do these examples, you don't have to do this in your work, obviously, but when we do these examples, I'm going to just use a short form to kind of point out what each one is. So I'm going to call common factoring CF, just so you know. And examples of this would be like 2x squared plus 10, although that one has a common factor, but not a very interesting one. A better example, 2x squared plus 10x, for what we're doing at least. Okay, so both of these have a common factor. The first one, the common factor is just a number. So with what we're doing, that's not going to help much. The second one has a common factor of x. Every term has an x in it. And notice that that's just 2 terms. Sometimes you'll have things that have 2 terms. Sometimes you'll have things that have 3 terms. Probably not more than that, but okay. So that's what common factoring looks like. And how do you recognize it? Well, do you know what an even number is? I hope we know what an even number is compared to an odd number, right? Odds are 1, 3, 5, 7, 9, and so on. Evens are 2, 4, 6, 8, 10. If the number ends in an even number, so 0, like 10 is even, or 20 or 30 or 40, or 2, 4, 6, or 8, if it ends in an even number and all of the numbers are even, there's a common factor of 2 at least. Okay, so that's one thing I would look for. Are all the numbers even? Multiples of 3 is a harder one because we're probably not as good at multiples of 3. And something like 72, unless you know, it may not be obvious that it has a 3 in it, that you can divide 72 by 3, unless you happen to know that you kind of can. So as it comes up, you know, I'll try to help point it out. But again, this is where it does get a little bit trickier. Multiples of 5, that one should be easy because everything will either end in a 5 or a 0. So if I've got 15, 25, and 30, those are all multiples of 5, right? Counting by 5s. That one hopefully is easy to catch. And the other one that you might see that's easy to catch beyond that, like 6, 7, 8, 9, those ones would be trickier. They don't come up very often. 10, but multiples of 10, we can see that usually too, because it'll be like 10, 20, 30, 40, 50 or something like that, right? So we can usually catch multiples of 10, multiples of 5, multiples of 2 because it's even, okay? And hopefully that's going to be like 90% or more of the times when you'll have a common factor, okay? Simple trinomial, we'll just call this ST. That's just for today. We don't really call it that throughout the course or anything like that. Has 3 terms. Well, it's a trinomial, so I hope it has 3 terms. That's what tri means, like tricycle, right? 3 wheels. Triangle has 3 angles, is a shape of 3 angles. So tri is the prefix for 3. So trinomial has 3 terms, and the coefficient of x squared is 1. So for example, x squared plus 7x plus 12. What about this example? 2x squared plus 10x plus 12. This one has a common factor of 2, and then it's going to be a simple trinomial, which is factorable. So this is what I mean. Like sometimes it's hiding, but I would, if you could do complex trinomial factoring with that, but complex trinomial factoring is a lot harder than simple trinomial factoring. So if I notice the common factor of 2, and I factor it out, so this would be equal to 2 times x squared plus 5x plus 6, then I have a simple trinomial left to factor. An example of something that is not is like 2x squared minus x minus 6 or something like that. Because I can't common factor a 2 out of that. So that one's a complex trinomial. That's the difference. This is what we mean when we say the x squared coefficient is 1. There's a 1. There's nothing in front of the x squared term, so it's a 1. We just don't write it. It's 1x squared. This is 2x squared. The coefficient is a 2. So it's not a complex trinomial. And the only other trick is once in a while you might have a number in front, but you can common factor it out, and then you're left with a simple trinomial. Does it seem easy to you, or what do you think about this? Because in my experience, people are very good at simple trinomial factoring. Difference in squares is awesome. It's the easiest thing you can do. Common factoring is even pretty easy once you get rolling, especially the ones we see are going to be simple compared to some that you've done in the past. Complex trinomial factoring is a little bit harder, but you can get very good at it. But then all of a sudden you mix them all together and that's when people start to get much more confused, in my experience. Okay, let's keep going. Complex trinomial, again, has to have 3 terms. So if you've got something with 2 terms, it's neither simple nor complex. It's something else entirely. As soon as you have 3 terms, you're thinking, is this simple? Is this complex? Is it a trinomial I can factor? Right? 3 terms is a big indicator of what kind of thing you're going to do. And as we talked about, x squared coefficient is not 1. So that one that we had up there, 2x squared minus x minus 6, is a complex trinomial factoring question. And that's what we were doing yesterday. And everything we were doing yesterday was complex trinomial. Now you have to figure it out. Then difference of squares. There's 3 criteria for a difference of squares. You got to have 2 terms. Both terms are a perfect square. And that means the whole number part is a perfect square and the whole variable part is a perfect square. And there are many different ways that this can look. For the most part, ours will remain relatively simple. But there are, if you remember in grade 10, when we do the factoring unit, we also challenge you to factor much more difficult ones that don't come up in the other units. But it's good factoring practice. So there are trickier versions of all of this. But if you kind of keep it in the more simple areas, then difference of squares will look a little bit more the same always. So those three criteria, two terms, you got to have two terms. Both of them perfect squares. As I said, that means the whole number part and the whole variable part is a perfect square, and you got to have a minus sign between them. Now, if the minus sign's on the wrong one and you can flip them, that's still a difference of squares. Okay? So for example, the most simple kind would be like x squared minus 9. This is the one that we first learned is just x squared minus just a number. And it's a difference of squares because this x squared is a perfect square and 9 is a perfect square. And there's no other junk in there, and there's a minus sign between them. So that's a difference of squares. What would be another one? 4x squared minus 9. So the coefficient of the x squared term is also a perfect square. So that one will work. If I want to come up with some examples that are not x squared minus 10, why is that not a difference of squares? Jada? Yeah, 10 is not a perfect square. What are the perfect squares? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I think we already did this probably. 5 squared is 25, because we talked about this earlier in the course. 6 squared is 36, 7 squared is 49, 64, 81, that's 8 squared, 9 squared, 10 squared, and you can keep going, but we'll stop there, 12 squared. Okay, and if you're not sure, check on your calculator. Just punch it in. Square root of whatever number you're given. If it gives you a decimal, not a perfect square. If it gives you a whole number, perfect square. Here's another example of one that is not 5x squared minus 9. Because 5 is not a perfect square. Or x cubed minus 9. X cubed is not a perfect square. We won't really see that anyway, but just as an example. Okay, the fact that it's x squared is what makes it a perfect square. Here's another example of something that is a difference of squares. So I've got a variable part on each, but it's x squared and y squared. So that's all good. If I had 4x squared minus 9y, no, because everything in there is a perfect square except the y. A single y by itself is not a perfect square. Does that make sense? Okay. Oh, and we'll call this one just like ds, and we'll call this one ct, and we got the other ones. Little short forms for those just for while we're thinking about this. Any questions about that? I don't know, if you think it seems easy, all of a sudden it becomes trickier. But since you've seen this before, that will make it a lot easier. Just the fact, even if you weren't great at it in grade 10, and some people get this fixed mindset that they're like, I never learned to factor, I can't do it, I'm never going to be able to do it. That's not true. You would be amazed going after it a second time, even though we do it a lot faster. In grade 10, you take like a whole week doing all of this, and we're only doing a couple of days. But you'd be amazed. A year older, you've seen it before, how much of a difference that makes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions that we're going to do here. And the first thing we have to do is determine which type of factoring it is. And it might be more than one. And this says factor fully. So this means if you factor once, but you could factor again, you have to. So you have to keep going. Factor until there's nothing left that you can factor. Usually that just means, for us, that'll just mean common factor and then factor what's left if you can. So what do you think about this one? And how do you know? Like, what do you notice about it? What stands out? What is important about this question that's going to help us determine what kind of factoring it is? Sarah? Always look for common factors first. Very good. So even if you're not thinking about what kind of factoring it is, you would look for a common factor. And do you see one, Sarah? Yeah, because remember what I said, both have to be even, and 2 and 10 are both even numbers, and there's an x in both. What else do you notice before we actually go ahead and common factor it?
There's a plus sign.
Plus sign, which means what? Not a difference of squares, because difference of squares has 2 terms like this, but you need a negative sign, so it's not going to be difference of squares. Good observation. What else?
It's also not a simple trinomial because it has 2 terms.
Yeah, it's not a simple or complex trinomial because it only has 2 terms. So we can make a lot of observations about what kind of question this is, and the only thing that's left is common factoring, which this has. Once in a while, you will get, and not even once in a while, in fact, we're going to do a whole day or two on what happens if it's not factorable. And if you remember from grade 10, we have a whole other tool that will work in those cases. So not everything will always be factorable, okay? Even for today, even while we're just factoring, once in a while, you're going to find something that's not factorable. So you have to be able to determine that, hey, this thing's not factorable. But this one is, so I go equals, and I pull out as much as I can out of the numbers, so 2, and as much as I can out of the variable parts. So I can pull out an x. And factoring is always about writing it in a way where if you re-expand, you get back what you started with. So what do I put in brackets like this? So that when I go 2x times the brackets, I get back 2x squared plus 10x. We're thinking division here, but you can also think, what do I put in here so that I get back that? Ellie, what do you think? X plus 5. And because it's so easy, I'm going to do a quick check. 2x times x is 2x squared. 2x times 5 is 10x. And this is where we're like, I'm awesome, I'm super smart, I'm great at this, I love factoring, and we just move on to the next question. But what are we supposed to do? We're supposed to look again for common factor. So don't pat yourself on the back yet. Is there anything else in there? Like, I'm particularly looking in the bracket, x plus 5. Can I factor that any further? No, not in this case, you can't. So we did as much as we could, okay? Somebody might have gone like this, though. 2x squared plus 5x. They factored, but that's not done because I still have x to pull out. Or somebody might have done this, x, 2x plus 10. Again, they factored, but they only pulled out the x. The other person only pulled out the 2. To factor fully, you got to take out both. And I'm telling you, this is tricky, this is hard, full honesty. But when I look in this bracket, I still see a common factor. When I look in this bracket, I still see a common factor. So that's why you look again and see if you're done or not. All right, let's move on. Oh, so this one was a common factor only. Next one. What do you observe? What's important about it? How many people, put your hands up, I won't call on you if you don't want me to, but how many people think they have an idea of what kind of factoring this is? Okay, most people. Good. Okay, who wants to tell me? Nick?
Simple trinomial.
How do you know?
Because the x squared value is not more than 1.
Yeah, it's a 1x squared and it's got 3 terms, so it's a trinomial. Again, I think a lot of people think that's obvious, but that's important. It's part of it, so I think it's good to throw it out there. That doesn't mean it's factorable. It may or may not be factorable, but this one is. Okay. Usually, if you get something that's not factorable, at least for today, there's a reason why it's not factorable. All right, so go ahead and factor it. Don't wait for me. Don't just copy me. This is what I would do for simple. Again, you need to know the difference between how you do a simple and how you do complex. And we did simple way earlier. We did complex yesterday. So what I do is I usually write out the brackets and write out the x's. And then what am I looking for? Who can tell me what I'm looking for? Zach?
2 numbers that multiply to negative 14.
Very nice. 2 numbers so 2 numbers are going to go here and here. And they have to multiply to negative 14 and add to 5. Because they're multiplying to a negative, they're going to have different signs. So one of them's, I don't know which yet, one of them's going to be positive and one of them's going to be negative. I don't usually put the signs in ahead of time like that, personally. Some people do, I just don't. So it's up to you. As long as you're getting the right answer and you like your way, go for it. I usually put the numbers in and then do the signs after, but you can do it however you want. How many people have it done already? Okay, do it. Do it. If you're not done. There's not very many combinations of numbers that multiply 14. 1 and 14 is 7 and 2 is it. And 7 and 2 has a difference of 5. Because it's negative 14, I'm looking for a difference. So it's definitely 7 and 2. How many people got 7 and 2? And then where do I put the negative and where do I put the positive? Noor? Why would you do that? Good, but what kind of 5 do I want? Negative 5. So what I'm going to do, and this is a great strategy, put whatever signs you want in there and check your answer like we were doing yesterday. So just watch me check, and I'm going to go 7x, negative 2x, 7 minus 2 is, whoops, positive 5. So I've got my signs backwards, and then I'm just going to go in and erase, because I'm using a pencil or an erasable pen, and fix it and check again. Okay? And for this one, simple trinomials are probably easier than complex as well to figure out where the signs go. You just got to make sure it matches the sign of the middle number. Okay, so that was a simple trinomial. And check again for common factors when we're done, but that one's done. Annette, what do you think? Why do you think that? Very nice. Right. What else do you notice, though? Before we move on, what else do we notice? Oh, and both ways will work. So you could do this as a complex trinomial, but if you notice the common factor, how did you notice a common factor? Yeah. Two, they're all even. This is what I'm saying. They're all multiples of 2. They're all even. 2 goes into 20 and into 48. So we can do a common factor first. Did you have a question?
Yeah. If we didn't common factor, then we just did
You know what? How about let's try it after. Whoops. And let's see what happens. So I have to divide the 20 by 2 and I get 10, and I divide the 48 by 2 and I get 24. Are we done? What does it look like that we have left now? Simple trinomial. It's 1x squared. That's nice. It's easier than a complex trinomial. It's 1x squared. And it may or may not be factorable. This one is. This is a hard one, actually, because there's 2 options of numbers that add to 10 and multiply to 24. Do you know what they are? 4 plus 6 is 10. 4 times 6 is 24. What are the other 2 numbers? 2 times 12 is 24, and 12 minus 2 is 10. This is one of those tricky ones where it all comes down to the signs, because both work. But because this is negative 24, the signs are different. So it's not 6 plus 4 to 10. It's going to be 12 minus 2. Although that doesn't mean it's a minus 2. Sorry, it's like, well, I'm subtracting. So it's 12 and 2. Which one's negative?
2 is negative.
Why?
Because you want to get 10, so 12 minus 2 is 10.
But 12 minus 2 is positive 10. So put it in there, do your check, and then swap them and check again, because it's so easy to put signs in and erase them. That's what I do. That's why I wait to do the signs at the end. Remember, it's got to match the sign of the middle term. Yep.
Maybe opposite of
X minus 2 and x plus 12 would look like this. Watch. Don't write this down. X minus 2 and x plus 12. X times x is x squared. x times 12 is plus 12x minus 2x minus 24, which is x squared plus 10x minus 24. Is that the same thing as, as that? It's very close, but it's not the same. So you can't get the signs wrong. The signs have to be right. What you could do is you could have x plus 2, like that's fine, to have just them written in different order. Zach, yeah.
I was just going to say the signs for the negatives for the total.
Yeah. Then the other question that was asked, so you don't have to write this down, but you can watch if you want. What if I was going to do a complex trinomial factor? So that's when I have to write down all the factors. So 1 and 2 and 2 and 1, and oh dear, this is a disaster because 48 has a lot of factors. I'm not going to write them all down. I'm just going to go 1 and 48, 2, well, maybe I am going to write them all down. 3 and 16, 4 and 12, 5 doesn't work, 6 and 8, that's all of them, I think. So now I'm looking for some, at least there's only a couple on the other side, that adds to 20, because I'm back up at the first line. So it's quite a bit harder, right? So something that adds to 20, and I'm thinking it is that one and that one, because 1 times 12 is 12. Oh, no, wait, I'm looking for a difference. So that's wrong. Looking for a difference of 20. So 1 and 24 is 24. And 2 and 2 is 4, and 24 minus 4 is 20. Okay, so I've got x and 2, and I've got 2x and 24. And then I figure out the signs, and I think the signs would work like that. So if I did complex trinomial factoring and didn't notice the common factor, that's what it would look like. But what do you notice now? Does anybody notice anything? No? The common factor is right there. That's very good. There's still a common factor in this. And that's hard to spot. This is what I'm saying. Most people wouldn't spot that because we just forget to look. Like even I don't really think about it because I just look for common factors first. So I rarely think about looking for them after. So it's way better if you can spot the common factor first. Okay, let's keep going. What is this kind? And again, what do you observe about it? Zach, what do you think? Even just any observation.
Those 3 terms.
3 terms, bam. That's one of the things we want to think about. Does it have a common factor? You've got a 5, a 9, and a 2. There's nothing common in those. So then what kind of factoring is it? It's complex or a tricky trinomial, that's right, because it's 5x squared, not 1x squared. So this is the one like we were doing yesterday, where I write out the terms and then the other side, and I only have to flip one side, so I'll flip the 2. There's only 1 for 5, there's only 1 for 2, so this is one of the easier ones, not that many factors. But again, the 2 is negative. What does that tell me?
That's a difference.
Yeah, the signs will be different, and I'm subtracting to get 9. This time it's positive 9. So it's obviously going to be 1 and 5. So 5 times 2 is 10, and 1 times 1 is 1, and 10 minus 1 is 9. My middle term, so those are the ones that I want. So it's x and 2 and 5x and 1. And it's 10 minus 1. I want the 10 to be positive, and that's the 2 times 5, so this one's positive and this one's negative. Complex trinomial. Yes?
if we used 1 and 5 and 2 and 1, but in the other order, so that it was 2x take away 1.
It wouldn't work. There's nothing else will work. You try it later, maybe not right now, and expand it, and you'll see that it won't work. The only thing you can do is the brackets don't have to be in that order. 5x minus 1 times x plus 2. That's the only thing that doesn't matter. Which bracket the sign is in matters. Which numbers are where matters, and there's only the one answer there. Keep going. Before we do any more of these, let's just look at the 4 that we have up here. What do I observe? How many terms does E have? 3. How many terms does F have? 3. So they might be trinomial type factoring. How many terms does G have? Only 2. Not a trinomial. How many terms does H have? Only 2. Not a trinomial. So they're very different. And this is where you start to, like, when you're looking at several at a time and you're looking at the differences between them and the tips that, gives us a heads up of what kind it is. What else do we always have to think of first? Common factor. So does this one have a common factor? 12 and 6 both can be divided by something that's the same, but not 17. So it's got to come out of all of them. So E has no common factor. What about F? It does have a common factor. How do we know?
They're all even.
They're all even. So we'll do that when we come to it. But that one does have a common factor. So let's do that first. What about G? Common factor? No. What about H? Common factor? No. But those ones look like difference of squares, don't they? Because 2 terms and there's a minus sign between them. Okay, let's go back to E. So E is going to be what type?
Complex.
Yeah, complex trinomial. Go ahead and try that one. So here's what I'm seeing. I've got 8 and 9, and 8 plus 9 is 17. So I've got 3x and 2, and 4x and 3. The 6 is positive, so the signs are the same. So when I multiply them, I get a positive number. 2 negatives makes positive, 2 positives makes positive. The middle term is a negative, so both numbers must be negative. And you can double check that there's no common factor in the end. If there wasn't a common factor in the beginning, there won't be a common factor in the last step either. But maybe it's a good habit of always checking. Okay, let's move on. F. So we said all the numbers are even, which means it has a common factor of 2. But what I'm going to check is there anything bigger? What might be bigger that could go into all of them? 4. So does 4 go into 12? Yeah, we probably know that one. Does 4 go into 4? Yeah, that's why you pick it. But I don't know. Does 4 go into 56? Like, this is one that we may not know off the top of our head, but Jess, yes, it does. Do you know how many times? Did you do it already? 14, very nice. So I can pull out a 4. If I only pull out 2, that'll help. That'll make all the numbers smaller, but it's not all the way done. So if you want to find the biggest number. And look at this. Look at how easy this makes it. 3x squared is way easier. Plus x minus 14. And now I've got a 3, which is way easier to work with, right? Three and 2 is 6. 1 times 7 is 7. 6 minus 7 is 1. I'm going to try to get through the last few quickly because I want you to have a little bit of time to work at least. Everybody okay? Take a look at these last 4. What do you notice about all 4 now that we're looking at these ones? They all only have 2 terms. So no more trinomial factoring for us. But are they all a difference of squares? Why don't you put your pencil down and just watch? So I'm going to run us through this quickly. That is a perfect square. That is a perfect square. Remember when we wrote out the list and there's a minus sign between them. So that one looks good for a difference of squares. 9 is a perfect square. X squared is a perfect square. 1 is a perfect square. Minus sign. 9 is a perfect square. X squared is a perfect square. Minus sign. 6 is not a perfect square. So I is not a difference of squares. Perfect square, but not a difference. That one's being added. Not a difference of squares. So some of these are and some of these aren't. Remember we said this one is difference of squares. This one is a difference of squares. Does anybody see what I is?
Common factor.
You can common factor I, and we'll do J in a minute. So who remembers how to do a difference of squares? Sarah?
You would take both of those.
Yeah, so the square root of x squared is x. Square root of 25 is 5. And then how do I write it? X plus 5, x minus 5. What about this one when it's got a 9x squared? Does anybody know what I write in the first spot? Very good. So I take the square root of 9, which is 3, square root of x squared, which is x, plus 1, and then the same thing in the next bracket, except minus 1. What's the common factor in this? See, this one's like trying to trick you, right? It's trying to look like a difference of squares, but it's not because of that 6. There's nothing you can do to change that or fix that. So I can pull a 3 out, and I'm left with 2x minus 3, which is no longer factorable. 2x squared, sorry, minus 3. So that one's done. And does anybody know what the right answer for J is?
Not factor.
Very good. It's not factorable. This is the kind that you might see like on a worksheet or something that's not factorable, because it's a sum of squares, which is never factorable. What I will never give you, or not yet at least, is a question that looks like that, but that isn't factorable. So that or like this. So you have to write out all of this and just not find the factors. I'm not going to give you that. Later on in a few days, next week, it won't be till next week, I'm going to show you a trick about how you can tell if something is factorable or not. Because there's a trick for it, but we're not going to do that today. Any questions?